Welcome to our screencast about the Variability Extraction and Analysis Toolkit, VEXA for short. Developed by FZI, VEXA facilitates various tasks of variability extraction, feature analysis, metrics generation, and visualization. In this video, we are going to discover some of VEXA's capabilities and how they can be utilized in a feature effect analysis of the lightweight IP source code, which we'll use as a case study. On the slide, you can see the overall VEXA methodology. VEXA is a collection of complementary algorithms with the purpose of facilitating variability extraction and source code analysis. Toolkit covers two main pillars of the overall methodology you can see on the slide. A detailed explanation is given in our previous video. In this video, we are going to put our focus on the new feature effect analysis in VEXA. So what are the main features? VEXA is a collection of extraction and analysis procedures or functions for variability extraction, feature effect analysis, code metrics generation, and exploratory code dependency analysis. In this video, we are focusing on the feature effect analysis introduced by Nadi et al. A detailed information on feature effects you can find in the paper. VEXA is a plugin for the Neo4j graph database. So the runtime environment can be a server or standalone application. Supported operating systems are Windows and Linux. VEXA can be integrated in other tools, and all VEXA functionality can be called from other programming languages like Java, C++. Also, VEXA supports the REST API or the Neo4j REST API or the binary bold protocol. For example, the VDEV integration is realized via the bold protocol. So for our use case, we are going to calculate feature effects using the VEXA toolkit. As a case study, we're going to use the lightweight IP source code. Lightweight IP is an open source TCP IP stack specially designed for embedded systems. So let's dive in and do the live demo. For our live demo, we are going to use the Neo4j desktop application. In the Neo4j desktop application, I already set up a remote database with the VEXA toolkit installed and all other dependencies configured. We can activate the connection and establish it via the bold protocol. We open the Neo4j browser so we can type in our VEXA queries. For this screencast, we're going to run it in tutorial mode so you can follow along. As I mentioned before, VEXA is a collection of functions and procedures. So a good starting point is to call the VEXA procedure help and check out all the procedures available. We can see here it will list all the procedures, some explanation, and the function signature. It's a good starting point to get to know the toolkit. For use case, we need to set up the database first. I'm going to run some queries, but I'm not going to explain what they're doing. You can find a more detailed explanation on the revamp website. So at the end, we clear the database so we can start fresh. So for our lightweight IP use case, the first thing we need to do is create a project. In VEXA, you can create projects using the VEXA project create procedure. We do that, and we can see a new node was created. Project node without any resources, you cannot do any analysis on it. So the next thing we need to do is add resources. We're going to add this resource, this lightweight IP root folder, to the VEXA project. Now that we added the resources, we can do a quick visualization. We can see here, that's the project. We can see here, the other node is the resource. You can add arbitrary many number of resources to a project and let VEXA analyze all of them. For our use case, we just use one. After we added the resources, we need to initialize the project. By initializing the project, VEXA will analyze the resources themselves and figure out if they have sub-resources, for example, like folders with source files in them. So we run the initialization. So we can see VEXA analyzed the resource and created around 800 nodes and around 1,600 relationships. We can also do a quick visualization. You can see here, for example, VEXA will use adapters to adapt the resources and generate other nodes. Yeah. So, but we are interested in a feature effect analysis. So the next point we need to do is the extraction. In the root folder of the lightweight IP, a lot of source files. We can take a look, and what we are going to do is match all source files with the extension C, HCC, or HH, which means that we're going to match all C and C header files, and then call the VEXA procedure resource adapt iterate, which will analyze all those files. So let's run it. It will take a few seconds. After the extraction step is finished, we can see that VEXA processed around 450 files and extracted the variability information. We can have a quick look, for example. Let's get some file. Give them a name. So, for example, this one, this TCP helper function. VEXA analyzed it using this adapter. And created the variability information. So in the project, it can happen that there are a lot of files, like you can see here, there are like README files. There can also be test files for test cases. So for our analysis, we want to exclude them. VEXA has a function for it, or a procedure, that allows you to activate and deactivate adapters. We're going to utilize this function to exclude all test files of the lightweight IP source code from our further analysis. We run that query by matching a folder which is called test, then running a subgraph search until we reach our adapter and deactivate all adapter nodes. As we can see, VEXA will return the deactivated adapters. We can expand them and we can see, okay, this one adapted the test etharp function or file, and now we can see because it is deactivated, it didn't generate any information. And this is crucial for our further analysis because we want to exclude all the test files. So the next step is the feature analysis itself. For feature effect analysis, we implemented a VEXA procedure called analysis calculate feature effects. The feature effect analysis is based on the work of Nadi et al., and further information can be found in this paper. Before we can calculate the feature effects, we need to calculate the presence conditions first. And a presence condition is a condition under which a code block is present in the configuration. To calculate that, we have also a VEXA procedure called VEXA analysis create presence condition. We can run it. We need to match all code blocks in the whole source, in all source files, and then create the presence conditions, which will be done in parallel. So let's run it. So VEXA analyzed around 8,000 code blocks and created the presence conditions. We can also have a quick look. Let's find some code block. For example, here. And we can see this code block has now a condition, a presence condition. In this case, it's a simple one. It's just lightweight IP alt CP. So with the presence conditions in place, we need to run another analysis before we can calculate the feature effects. VEXA uses symbols to identify preprocessor symbols. So for example, in this case, it was this lightweight IP alt CP. If I expand it, you can see here, that's the symbol. And in the whole source code, a symbol can occur multiple times. But for feature effects, we need to, let's say, unique symbols. So we run the merge procedure. In this case, no VEXA functions are used. You can do it in pure Cypher and merge all symbols together. So let's run it. So VEXA merged around all symbols into 1,200, around 1,200 symbols. And now we can see them as unique features and calculate the feature effects for that unique symbols. VEXA will use the Z3 solver from Microsoft in the background to evaluate the formula and simplify it. So let's try it and calculate 10 feature effects. It will take some time. So for the first 10, we can see the feature effects. So for this case, for example, the lightweight IP implies this long formula. The formula on the right is in SMT lib2 format and can be hard to read. But for example, we can see here, this feature implies that this symbol is set to 0 and is negated. So we can use the VEXA functions to calculate the feature effects. Now we can also calculate all the feature effects in the whole source code. We can run the whole query and sort our results. So VEXA finished the calculation after some time, and we can see the results here. So let's go full screen. So we calculated now all the formulas, there are a lot of them now, and the whole source code. and sorted them accordingly. So you can see now, for example, there are some features which cannot be satisfied, which are always false, or some high-level features which are always true, like this one. So in this case, it's not a real feature because it's always true, always there. So there is no constraint for it. So all in all, you can see you can use the VEXA functionality to calculate it. VEXA will call the solvers in the background, evaluate the SMT formulas, and try to simplify it and display it here. Sometimes you can see there's some error, and this occurs. Let's have a look. For example, here. This occurs if information is missing. So VEXA will analyze the whole graph database, all the interdependencies, all the presence conditions, and so on. And if some symbols are not well defined, for example, you don't know the type of this one, VEXA cannot calculate the formula because the SMT solver will not be able to simplify the formula in the background. So that's it for our screencast. Let's switch back to the slides. In this screencast, we demonstrated how to use the VEXA toolkit to generate feature effects for the lightweight IP source code. We demonstrated how to run the VEXA queries in Neo4j browser, but you can also run the whole analysis in batch mode and generate the result files directly. For further information, you can contact FZI using the contact information shown on the slide. Thank you.